Module 3 Mastery Assignment. My first topic is Taylor polynomials, which are a polynomial whose coefficients for each term are constructed using a series of derivatives of the approximated function evaluated at the center C. A Maclaurin polynomial is a special case of a Taylor polynomial, and it is always centered at C equals 0. A power series is an infinite series where a variable is raised to the power of the index variable. This is the setup for a Taylor series. It's basically the summation of n equals 0 going to infinity of f to the power of n times c, and then that's multiplied by x minus c to the power of n, and that's all over n with the exclamation point, the factorial. And the example I chose was f of x equals e to the x at x equals 0. So you first need to evaluate this at x for 0, 1, 2, 3, and so basically you get n equals 0, 1, 2, 3, and then you evaluate this function at 0, and you also get n equals 0, 1, 2, 3. So this means e to the x equals the summation of n equals 0 to infinity of 1 over n factorial multiplied by x over n. And you can simplify this to the summation of infinity n equals 0, x to the power of n over n factorial. My second topic is partial sums, which are the sum of a certain number of terms in a series, and this is denoted with a capital S. Partial sums are used to determine if there is a sum for an infinite series. My example is finding the partial sum of n plus 1 squared. So the first summation is we just plug in 1, which is the first term, so you do 1 plus 1 squared, and that equals 4. The next one, since it's a partial sum, we have to go back to the one before it, so we do 1 plus 1 squared, which you know is 4, and then we add that to the second term, 2 plus 1 squared, and we get 13. And so for the third term, we do the 1 plus 1 squared plus 2 plus 1 squared plus 3 plus 1 squared, and we get 29. So basically, to find the next term in the sequence, you have to take the previous terms.